Mars and Its Canals by Percival Lowell, Chapter 8, Climate and Weather. In gazing at the successive phases presented by the polar caps, as their annual history unrolls itself to view, beginning with vast white cloaks that in winter hide so effectively the planet's shoulders, to little round knobs that in summer sit like guardsmen's caps, more or less askew upon the poles, the bodily eye sees only the glisten of far-off snow. The mind's eye, however, perceives something more, the conviction they carry of the presence of an atmosphere surrounding the planet. Elusive as water vapour is to sight for its transparency and to spectroscopic determination for its earthly omnipresence, recognition of its existence elsewhere by deduction raises such reasoning at once to a more conspicuous plane than it might otherwise assume. Especially is this true when the deduction is itself conclusive, as is here the case. For it depends on a phenomenon not its own, but which are in their turn dependent on it. We are not even beholden to any knowledge of the substance composing the caps for the fundamental inference that an atmosphere surrounds them. Whatever that substance were, the fact that the caps dissipate and reform shows us with absolute certainty that they pass into the gaseous state, to be later solidified afresh. This gas consists of itself an atmosphere, while another phenomenon, to wit their blue girdles as they melt, affirming their substance to be snow and ice, enables us to précis the fact that this gas is water vapour. From such premise given us by the polar caps, we are able to infer much more by the help of the kinetic theory of gases. But the speed of parting by a planet with its gases is conditioned by the mean speed of each gas. Water vapour will therefore go before nitrogen, oxygen, or carbonic acid gas. If then we find it present over the surface of a planet, we are assured of the possibility that the other three may be there too, and from the similarity of matter in space, strong reasons to suspect that they actually are. Corroborative evidence of the accuracy of the deduction as to the presence of a Martian air is shown in several other ways. In the existence of clouds, to begin with. Rare as they are, these certainly float at times over parts of the planet, although it is doubtful whether they can be seen. Fortunately for assurance, we have other ways of ascertaining their presence than that of obscuration. Nor is it of account to the argument that they should be few and far between, as they unquestionably are. One single instance of such mediumistic support is enough to support the theory of a medium, and that instance has been more than once observed. Direct evidence of atmosphere is further forthcoming in the limb light. This phenomenon might be described as a brilliant obscuration. It is a circlet of illumination that swamps the features as they near the full edge of the disk, the limb of the planet, as it is called. Obliteration of the sort is evident more or less markedly at all times, and is not due to foreshortening as the broadest areas are affected. The fading out of the detail at the limb suggests nothing so much as a veil drawn between us and it, lighter in tint than what it covers. Such a veil can be none other than air, or the haze and cloud that air supports. From its effect, impartial in place and partial in character, cloud is inadmissible as a cause, and we are left with air charged with dust or vapour in explanation. Obscuration due to it should prove most dense at the limb, since there the eye has to penetrate a greater depth of it. Just as on the earth our own air gives azure dimness to the distance, in deepened tinting as the mountains lie remote. Another bit of evidence lies in the apparent detection of a twilight arc. In 1894, measures made of the polar and equatorial diameters of the planet showed certain systematic residuals, left after all known corrections had been applied. The only thing which would account for them was the supposition that a twilight arc had been unconsciously seen and as unconsciously measured. In delicate quantities of the sort, too, great reliance cannot be put, but if the residuals be not referable to other cause, they give us not only further evidence of an atmosphere, but at the same time our only hint of that atmosphere's extent. From them it would seem that the air must be rare, not more than about 4 inches of barometric pressure as we reckon it, and probably less. A thin, high air, more rarefied than prevails upon our highest mountain tops. Corroborative of this is the aspect of the planet. From the general look of the disk, a scant covering of air is inferable. For one of the striking things about the planet's features is their patent exposure to our sight. Except in the winter time of its hemisphere, or in the spring after the greatest melting of the polar cap, nothing seems to stand in our way of an uninterrupted view of the surface, whether in the Arctic, temperate or tropical zones. From the openness of its expression, however, too much case should not be made, as we really know but little of how an atmosphere-enshrouded planet would look. We find no difficulty in seeing objects 100 miles away across the surface of the Earth, and yet the thickness of the air strata in such horizontal traversing is manifold what it is when we look directly up. It is also out of all proportion laden with smoke. In the purer regions of the earth, a clear air imposes but little bar to sight, and conjures dust up far things startlingly distinct. Nevertheless, every evidence points to a thin air upon Mars, a priori reasoning, indirect deduction, and direct sight. Now from the thinness of atmosphere it would follow, other things equal, that the climate was cold. About this there has been much question, but less of answering reply. From the distance of the planet from the Sun, it is certain less heat is received by it than falls upon the Earth, in something like a ratio of 1 to 2, but that the amount effective is as the amount received is far from sure. The available heat is much affected by the manner of its reception. A blanket of air acts like the glass of a conservatory, letting the light rays in, but hindering the heat rays out. The light rays falling on the ground or the air are transformed into heat rays that, finding the return journey less easy, are consequently trapped. All substances are thus calorifiers, but water vapour is many times more potent than ordinary air to heat and snaring. A humid air has a hothouse tangle to it, most perceptible. Now, what the relative percentage of water vapour in the Martian atmosphere may be, we do not know. The thinness of the Martian air has caused it to be likened to that upon our highest mountain peaks, which are in large part covered with perpetual snow. But the comparison is not well founded. A peak differs materially from a plateau in the countenance it gives to the heat falling upon it. On a plateau, each warmed acre of ground helps the retention of heat by its neighbour, while in addition to being destitute of side support, the higher winds generated about an isolated peak blow its own caloric away. Still less does any analogy hold between the two when the plateau is a worldwide one. From these considerations, it is evident glosses are possible upon the bald idea of a much lower temperature prevailing on the Martian surface than on the Earth's. Doubtless the theoretic cold has been greatly overdone. Reversely, recent observations tend to lower the apparent temperature disclosed by the features of the disk, and between the rising of the theoretic and the falling of the observed, we are left with a very reasonable compromise and reconcilement as a result. The various look and behaviour of the surface of Mars point to a mean temperature colder than that of the Earth, but above the freezing point of water, for reasons at least outside of the polar caps and during all but the winter months. Except at certain special spots, and possibly even there, frost is unknown at all times within the tropics, and except in winter in temperate latitudes. These anomalous localities mentioned in the preceding chapter may be said to be the exception that proves the rule of general non-glaciation. For if they be snow, they stand witness to its absence elsewhere upon the disk, and if they are not, they testify the more emphatically to the same effect. As between different parts of the surface, the tilt of the Martian axis and the greater length of the Martian seasons, the one the same as and the other the double of our own, tend to an accentuation of the heat in the temperate and Arctic or Antarctic zones. The greatest insolation on Earth is not, as we might suppose, at the equator, but at the parallels of 43.5 degrees north and south. Even the poles themselves receiving a quarter as much heat again on Midsummer's Day as ever falls to the lot of the line. This broad physical fact is equally true of Mars. While in the matter of consecutive exposure, Mars in summer outdoes the Earth, for the longer the seasons, the more nearly does the effective heat approach the received amount. Thus, both on the score of heat received and of the heat husbanded, these zones must be relatively warm, and this shows itself in the look of the surface. In summer, it is clearly warmer within the polar regions than is the case on Earth, to judge by the effect. In winter, the cold is doubtless proportionately severe. For the diurnal range of temperature, we have less data. There is evidence pointing to chilly nights, but it is meagre, and we are left to fall back on the cold of our deserts at night for analogic condition of the state of things over the Martian desert levels after the sun goes down. If we are uncertain of the precise character of the Martian climate, we know, on the other hand, a good deal about the Martian weather. A pleasing absence of it over much of the planet distinguishes Martian conditions from our own. That we can scan the surface as we do, without practical interruption, day in and day out, proves the weather over it to be permanently fair. In fact, a clear sky, except in winter in many places even then, is not only the rule, but the rule almost without exceptions. In the early days of Martian study, cases of obscuration were recorded from time to time by observers, in which portions of the disk were changed or hidden as if clouds were veiling them from view. More modern observations fail to support this deduction, partly by absence of instances, partly by other explanations of the facts. Certainly, the recorded one possible example has presented itself to me during the course of my observations, extending more or less over 11 years. Even in this case, there was no obliteration, though a certain whiteness overspread an area near the equator temporarily. Position seemed to point to its identity with a cloud, which made its appearance about that time upon the terminator and lasted for some 36 hours. The cloud, however, showed evidence of being not the kind with which we are familiar, but a dust storm, in keeping indeed with the desert region crisis in which it originated. With the exception of sporadic disturbance of the sort, the whole surface of the planet outside the immediate vicinity of the polar caps seems free from cloud or mist, and to lie perpetually unveiled to space. In the neighbourhood of the caps, however, and especially round about their edge, a very distinct pearly appearance is presented during the months at which the cap is at its maximum, or in other words, in the depth of its winter. Of a dull white hue and indefinite contour, the phenomenon suggests a cloud. Where it lies spread, no markings are visible, an absence explicable by obscuration due to interposed medium, but equally well by seasonal non-existence of the markings themselves, which from the general behaviour of these markings we know to be to some extent certainly the fact. Of the regions where the effect is noticeable, Hellas is the most striking. So conspicuously white during the winter of the southern hemisphere as to have been often mistaken for the polar cap, its ghost shows thus almost regularly every Martian year. What is as suggestive as it is striking, the balance is confined to the solid circle constituting Hellas, and does not extend into the dark regions by which it is circumscribed. Hellas is as self-contained when it is powdered as when in its normal ochre or abnormal red it stretches like a broad buckler across the body of the disk. That the land there lies at a higher level than its surroundings is pretty certain, but that the difference can amount to enough to explain its silveriness as ice is improbable. In latitude, Hellas is distinctly temperate, lying between the parallels of 55 and 30 degrees. But on Mars, this is no warrant of a like climate. Again, though close on the south to what constitutes the polar cap, it does not strictly form part of that cap, but occupies both in position and in kind a something intermediary between the frost-bound regions of periodic snow and the warmer ones of perpetual sunshine. It seems to be afflicted with the winter weather of the north of Europe, and to owe its pearly look at such times to the same cloud canopy that then distressingly covers those inclement lands. Similar in behaviour to it is the long chain of so-called islands that, beginning southwest of Thaumasia, runs thence westwards even to the eastern edge of Hellas. These belt the planet in a northwesterly direction by a strip of territory from 10 to 15 degrees wide, the medial line of which begins at 55 degrees south and ends in about 40 degrees. They are parted from the main bright areas by blue-green seas of about the same width as themselves, the Mare Cyrenum, the Mare Cimmerium, and Mare Tyrrhenum. Since the seas are not seas, The cause which might bound the snow, were they such, cannot be the cause here. Nevertheless, they have an effect of some sort on the isothermal lines, as is shown not only by latitude comparison with the state of things in Hellas, but with that in Thaumasia as well. For 30 degrees south is also the limit, apparently, of the white Thaumasia, where ochre deserts stretch 10 degrees further south still, the region in its southern part being white mantled, in its northern part not. Here again then, the ochre areas make exception to what affects the blue-green ones. Clearly, the blue-green regions temper the action of what gives them wintry cloak. But why they should do this is not easy to explain on any supposition terrestrial or maritime. Bodies of water tend to foster the formation of clouds, so less markedly do areas of vegetation. Neither the old ideas then nor the new lend themselves in explanation. It may be that while here we seem to be envisaging cloud, we are in reality looking at hoarfrost. On the other hand, light cloud would show less, superposed over a dark background, than over an ochre one. And this, the simplest of all explanations, may be the true one. It is facts like these that intrigue us in the study of the Martian surface, by revealing conditions which render offhand analogy with the Earth unsafe. Indeed, we are more sure of some things which appear too strange to be true than of others so simple on their face as to enlist disbelief. Among the most difficult and perplexing are meteorological problems like the above. Here we can only say provisionally that while cloud best answers to the appearance, frost best fits the cause. For vegetation might melt frost, yet not dissipate cloud. By raising our conception of the mean temperature, the facts can, however, be reconciled, and this is probably the solution of the difficulty, after all. As we saw in the annual history of the polar caps, a dimness somewhat different affects the northern cap in May and June. After the melting of the cap is well underway, a haziness sets in along its edge, which befuddles its outline and effectively hides what is going on within it. When at last the screen clears away, the cap is found to be reduced to its least dimensions. Such obstructing sheet looks to be more of the nature of mist, caused by the excessive melting of the cap. Unfortunately, there are here no patches of blue-green to test a possible partiality in its behaviour over such tracts. Nor has similar action ever yet been remarked in the case of a cap of the southern hemisphere. Regular recurrence at the appropriate season of the planet's year, together with extensive action at the time, takes this springtide mist to some extent out of the dominion of weather into that of climate, for it prevails all round the cap and repeats itself in places as each fresh spring comes on. At least it has done for the past 3 oppositions, at which it has been possible to observe well the Arctic zones. It is thus both general in its application and fixed in its behaviour. Nevertheless, it betrays something of the fickleness which characterises that most inconstant thing, weather. For it comes and goes, one thinks for good, only to find it there again some days later. Not less captious is the meteorologic action shown in the making of the new polar cap. When the northern one starts to form, vast areas of frost are deposited in a single night. These, however, are not permanent. The ground thus covered is during the next few days again partially laid bare. Then a new fall occurs, hiding the surface a little more completely than before, and the lost domain is more than regained. By such wave-like advance and recession, the tide of frost creeps over and submerges the Arctic regions as the late summer passes into autumn. In this alternate coming and going with succeeding days, we have an unsteadfastness of action most fittingly paralleled by our own weather. It would seem that local causes there, as here, are superposed upon the orderly progress of the seasons, and though at the oncoming of the autumn the cold is steadily gathering strength, nevertheless warm days occur now and then to stay its hand, only to be succeeded in their turn by frosts more biting than before. Even on Mars, nothing in the way of weather is absolutely predictable, but its impredictability. End of section 9.